here for solving using substitution. These are from page 300 of the text, and we're going to be looking at question 1G, and we'll also be looking at 1I after that. So we're just going to write down the question here for 1G. We've got 2x minus 5y is 0, and if you take y away from x, you also get 3. Okay. All right, now, step 1, as always, we've got to isolate any variable. All right, so which variable should we isolate? It looks like these two variables in the first equation have coefficients. There's 2 and this -5 here. So we don't want to isolate either of these. It looks like they'll just add some extra steps. So I would say something in this second equation where we don't seem to have coefficients. So I'm going to rewrite this equation. Now, I think it can be helpful if we see just a bare x or a bare y, or rather a negative y, that it could be helpful for us to remind ourselves that these have invisible coefficients in front of them. This is a 1x, or 1 times x, right? And this is a -1 times a y. And that's all equal to 3. And I think that could be really helpful for us in deciding what thing we should isolate first. Because what we want like 1x equals blank, or 1y equals blank. We want something like that, where the x, we just have 1x on the left-hand side or right-hand side, or 1y. And it's the same thing when you say x equals something or y equals something, where you really mean there's one of them. Okay, so with that in mind, we could isolate this y, but if we did that, we would get a -y on the left-hand side. Just to draw that point home, if I took away 1x from both sides, and it cancels this guy out, it leaves us with -1y equals 3 minus 1x. And then I'd have to divide away this -1 here. So that would be an extra step. So I think what we should do is we should try to isolate this 1x. All right. So I think a good plan of attack is to start with any adding and subtracting to get rid of. We got this subtracting 1y, so I think we should do the opposite of subtracting 1y. What's the opposite of taking away 1y? Adding 1y. So we're going to add 1y to both sides of the equation. All right. And that should cancel out 1y and -1y. So I like to write my equal sign first. And so that's going to leave us with this 1x on the left. And I've got 3 plus 1y on the right. Now, you might want to make that 4y. However, 3 and 1y do not count the same thing. This is a sum number of y's, and this is some number of whole numbers. Okay, so this is an isolated equation. So you can stop right there. 1x is the same thing as 3 plus 1y. Or, if you prefer, you could just say x is equal to 3 plus y. And those are two ways of saying the same thing. So you get to choose. The advantage to writing in this form is that we're never going to forget that there's a -1 in front of this y or a +1 in front of this x. All right. Now, the next step is we're going to want to substitute. So we're going to take that x and we're going to plug it into the other equation. So I'm going to write the equation in blue, and I'm going to take this 3 plus y, I'm going to replace that x in here with 3 plus y, and write the rest of the expression, -5y, and that's all equal to 0. I guess the difference between black and blue doesn't really resolve so well. Maybe I can try to focus. Maybe that could help a little bit. Not really. Okay, well, c'est la vie. All right, so what should we do first? A good first step is to distribute. So whenever we do a substitution, well, not every time, but typically we've got this 2 multiplied by this whole set of brackets. So I'm going to distribute that 2 into the set of brackets there. So that means I'm going to try to write the step I'm doing in red. So I'm distributing. It means I'm multiplying both things in a set of brackets by 2. So it's going to give us, well, I started writing 2 again. It's going to give it 6 plus 2 times y, which is 2y, take away 5y, and that's all equal to 0. So that's the distribute step. Now, the next thing we're going to want to do is group. We want to group like terms. So I would say the 2y and the negative 5y look like they can be grouped together. They're counting the same number of things. You can imagine having $2 and then spending $5 on something, like with maybe your debit card. And you can imagine you're going to be $3 owing the bank. You're going to be $3 in the negative, or what we say in the red. So we're going to still have that 6 here, but we're going to have minus 3y equals 0. And you know what? Maybe using a is not good, or 1 is not good, because we were using 1 here, and also in the question type. So maybe we'll call that a, not call that b. I think we called them a and b before. So step 3 is we should deal with any adding or subtracting. So I'm going to try to get this 6 away from this left-hand side, because really I want to get just one y. So I'm going to rewrite this equation down here. We're going to deal with this 6. So we're going to take away 6 from both sides of the equation. All right. It's going to cancel out the 6 and the negative 6. And what's really important is we keep this negative here. We are still left with a negative 3y. That's equal to 0 take away 6, which is negative 6. And then as a last step, we're going to have to ask ourselves, well, what do we have here? We have a negative 3, and there's an invisible multiplication between the y. So this really means negative 3 times y. That's equal to negative 6. So we're going to do the opposite of multiplying by negative 3. We're going to divide by negative 3. And we'll divide both sides by negative 3. And that's our step D, which is dealing with the multiplication / division. All right. And so it looks like these negative 3, we're going to divide by negative 3, cancels it out, leaving us with a y equal to negative 6 divided by negative 3. A negative divided by a negative makes positives. And 6 divided by 3 is, I can fit 2 3's into 6. All right. Well, I guess we were calling that the solve step. I forgot to label that solve. And these are all subset steps of solving. And last step, now that we've solved for a variable, is we're going to do back substitute. So that means we're going to take that 2 and we're going to plug it back in. We could plug it into one of the original equations, or to be honest, a little bit easier is we plug it into our intermediate equation, the variable we already isolated. Alright, so I'm going to say x equals 3 plus, but instead of y, I'm going to write the value of y, which is 2. That tells us x equals 5. And those are our two answers. X equals 5, y equals 2. Okay. So we'll move on now to question 1I, which is here. So, piece of paper here. All right. So we've got, oh, okay, so for 1I, looks like we've already got a variable isolated. We've got y equals 3x plus 4, and that variable is already isolated. And then we've got 2x minus 3y is equal to 2. Okay, so nice. Step 1, the variable is already isolated, so we could say we already have an isolated variable. So we're going to take that guy, and then step 2 is we're going to substitute it into the other equation where there is a y. So I'll write the rest of the equation as is, 2x minus 3, and then I've got a 3x plus 4. That's all equal to 2. Okay, then we've got to solve. So the first step, well, actually I'm going to rewrite that whole thing. And say we had this step which was distributing. Oh, shoot. I want to write these all in the same line, so I'm going to rewrite it again, which is a bit of a waste of time. Alright, I'm going to distribute. That's going to be my step 1. So I'm going to multiply this 3 into this set of brackets, like that. So that tells me I have 2x, which stays the same. And I've got negative 3 times 3x, which is negative 9x. And negative 3 times 4, which is negative 12. And it's all equal to 2. Now, my next step is to group like terms, and I might look and try to find terms that are like each other. And I would see these two x's here, 2x and this negative 9x, and they look like they're counting the same number of things. These two are counting the same types of things, but they're on opposite sides of an equal sign, and that's like a little brick wall. So they can't really communicate just by adding together, but maybe I could do something later to move that 12 over so it can communicate with 2. So I have this 2x take away 9x. And so what's that? 2x take away 9x. $2 and you spend $9 on an item, you're going to have negative $7 in the bank. And minus 12, that's not doing anything, equals 2. Then we'll do any adding or subtracting. So we want to get everything away. We want to get x by itself. So we'll add 12, do the opposite of taking away 12 from both sides. So we're going to add 12 to both sides. And then this negative 12 and this positive 12 cancel out. And so I have this negative 7x still here on the left-hand side. And I have 2 plus 12, or 14. Now, the next thing we have to do is recognize that this really means negative 7 times x, and we want to do the opposite of multiplying x by negative 7. The opposite of multiplying x by negative 7 is dividing by negative 7. We're going to divide both sides by negative 7. Negative 7 divided by negative 7 leaves 1 as 1x, which is what we're trying to get. And 14 divided by negative 7 is a negative number, because a positive divided by a negative is a negative. And 7 goes into 14 twice, so it would be negative 2. So I can think of this being 1x is equal to negative 2, or just x equals negative 2. Alright. Oh, I forgot step D, right? And then step 4, the last step, we're going to back substitute. So we're going to take that negative 2, we're going to put it back into one of our original equations. Usually I think it's easiest to use the equation we isolated in step 1, or use in step 1 I should say. So, at least in this case, so we've got this equation y equals 3. We're going to take that negative 2, plug it in. So times negative 2 plus 4. So we got to use BEDMAS here. I mean, we have to do the multiplication, 3 times negative 2, before we add. multiplication, then addition. So we got y is equal to, and 3 times negative 2 is going to become negative 6 plus 4. And negative $6, and you put 4 more dollars in that bank account, you're still going to be down 2. So you're going to have negative 2. So y is going to be negative 2 as well. So that gives us the value x equals negative 2 and y equals negative 2. Now, here's what I recommend. If you made it to the end here by using the video to help in I or G, stop now, put these sheets away, try to solve that system again without looking at these sheets. See if you can remember the things that we avoided here. Like we avoided, say, adding negative 9x to negative 12 because they weren't like terms. And the same thing with G. If you were able to use this video successfully to help you, go back now, try the same question, and try it without any help. And then check in. And repeat this process. This is how we learn to do this. You repeat the process until you can do it independently, 100%. Or at least independently at all. That's how we know that we're done studying. All right, well, good luck studying. And let me know if you guys have any questions.